NIDEC history. In 1800, United States Electrical Manufacturing was founded only with 17 employees in California. In 1855, Motors USA de Mexico began operation in Mexico with only 30 employees in a small plant located off downtown Monterrey. Then, in 1962, the industrial group Emerson Electronic of Louis, Missouri, purchased from USA. In this year, 2010, Emerson Electric sells some of its plants to NIDEC Motor. It is located in Boulevard Carlos Salinas, kilometer 9.7, Apodaca, Nuevo León. Product. Motors are used in a wide variety of fields, including an office equipment, home appliances, and audio and video equipment, and cars as well as industrial equipment. The NIDEC Group has a broad lineup from small precision motors used in telecommunications equipment to ultra-large motors from industrial systems. Project description. We are going to explain our investigation in base to the knowledge that we have carried during the semester in ergonomy class. For example, the methodology problem in NIDEC, results of the case that we choose, and our improvement proposal.
The method was developed to evaluate the exposure of individual workers to ergonomic risk factors associated with upper extremity MSD. The rule ergonomic assessment tool considers biomechanical and postural load requirements of job tasks on the neck, trunk, and upper extremities. A single-page worksheet is used to evaluate required body posture, force, and repetition. Based on the evaluation, scores are entered for each body part. In Section A, for the arm and wrist. In Section B, for the neck and trunk. Using the ruler worksheet, the evaluator will assign a score for each of the following body regions: upper arm, lower arm, wrist, neck, trunk, and legs. NIOSH lifting equation is a tool used by occupational health and safety professionals to aid the manual material handling risk associated with lifting and lowering tasks in the workplace. The primary product of the NIOSH lifting equation is the recommended weight limit, which defines the maximum acceptable weight that nearly all healthy employees could lift over the course of an 8-hour shift, without increasing the risk of musculoskeletal disorders to the lower back.
We have an analysis out of this problem. With a distance of almost 5 meters away, 188 inches is a lot of distance. So out of all these calculus, we find out that 2.115 pounds is the limit of our carrying, but we have 15 kilograms more or less. So we are pretty far from good.
We chose this method because it is focused on the upper limbs, which is the main part of the body that is used in the task we are analyzing. We are going to begin with part A, which consists of an arm and wrist analysis. For step 1, we have to locate the upper arm position. We add a point because the arm is located between the 20 degrees range, and because the arm is abducted, we add another point. That gives us a score of 2 for the upper arm. For step 2, we locate the lower arm position. We add a point because the lower arm is located in a 67 degrees range, and we add another point because the arm is separated from the body. That gives us a score for lower arm of 2. For step 3 and 4, we have to locate the wrist position and the wrist twist. We add 3 points because the wrist is located in an 18 degrees range. That gives us a wrist score of 3. And for the wrist twist, we add a point because the wrist is twisted in the mid-range. For step 5, we have to look up the posture score in table A. We have an upper arm score of 2, a lower arm score of 2, a wrist twist score of 1, and a wrist score of 3. That gives us a 3 for the posture score in table A. For step 6, we add muscle use score. We have a 0 for that. And for step 7, we add force or load score. Because we have a load greater than 10 kilograms, we add a 3 for that. For step 8, which is the last step in this group, we find the row in table C. We have a posture score for A of 3. We have a muscle use score of 0 and a force load score of 3. That gives us a 6 for the wrist and arm score. Now for part B, which is neck, trunk, and leg analysis, we begin with step 9, locating the neck position. We gave it a score of 2 because the neck is located at a 20 degrees angle approximately. For step 10, we locate the trunk position. We gave it a score of 3 because the trunk is located at a 24-degree angle. Now for step 11, we identify the legs position. Because both legs and feet are supported, we give it a score of 1. Now for step 12, we have to look up the posture score in table B. We have a trunk score of 3, a neck score of 2, and a leg score of 1. That gives us a table B score of 4. For step 13, we add muscle use score, which is 0, and a force load score, which is 3 because the load is greater than 10 kilograms. Now for step 15, we find the column in table C. We had a posture B score of 4, a muscle use score of 0, a force load score of 3. That gives us a neck, trunk, and leg score of 7. We located at table C. And we had a wrist and arm score of 6. Finally, we got a 7 for final score. That means that we have to investigate and implement a change.
Proposals are the first, we will reduce the weight, repositioning the mold, and adding a pulley and rail with the melting pot. Here we have a layout, and the red part of the layout is the part where we're going to be focusing in. AutoCAD shows 809.39 units. That's equal to 478 centimeters real life. That is a data that we're being provided with. First, we'll move the mold, so in that way it's going to be easier to dispose of the aluminum, and also it will be easier to use the result afterwards. So then we'll add the rail right in the middle of the two employees that are working, and in there we're going to put on the melting pot. This melting pot, it's going to be 18.21 units away from our employee, and that equals to 66.262 centimeters in real life. This positioning will represent a reduction on horizontal traveling, but we need also vertical traveling. This melting pot that we're going to use is 27 centimeters in height, so we're going to put it 40 centimeters in height from the floor. So that way it will be 67 centimeters and only 8 centimeters the difference between the furnace and the highest point of the melting pot. This furnace is 75 centimeters height. So this will imply a reduction from 15 kilograms and 5 kilograms also. How does it work? We using an RWL system, we find out that in conclusion, out of all this data, 14.519 pounds is the limit that we're going to use on our weight. In kilograms, that's 6.586. So we are under the limit, so we're okay. This will also mean arrays in the cycles that we're going to use to produce one piece. So it will be 3 times the number of times that the employees are going to be traveling to this melting pot. But this distance between them and the melting pot is less. So with all this energetic waste calculus, we find out that 6.10325 kilocalories per minute is going to be used. With this data, we found out that it is a really exhaustive work, but with only 16.19% of the time of rest, it's going to be good. This turns out to be 1 hour and 22 minutes, and right now these employees have 2 breaks, one out of 30 minutes and the other one 20 minutes. So just an addition of another 30 minutes break will be good to go.
After applying our empowerment, we eliminate certain risks, which are burned in arms, hands, and feet, falling when leaning on co-worker, like the video, and stumble with the step. Also, after applying our empowerment, DTA possibly eliminated disease is a low back pain, that is a strong rheumatic pain that affects the bones or muscles of the lower back, like the imagine. Carpal tunnel syndrome, that is caused by compression of the median nerve in the carpal tunnel of the wrist. Thoracic outlet syndrome, this occurs when the nerves or blood vessels just below the neck are compressed or tight. If you think this is a lot, the cost of a single operation of carpal tunnel syndrome costs approximately 30,000 pesos. You need to take care of your workers, do you think? Well, the cost of our empowerments includes the hoist price, the steel beam, in this case are 2, the chain, the metal input, and the installation, and do a total of 32,455.5 pesos, and possibly eliminate tenosynovitis, that is the inflammation of the tendon of the synovial membrane that's covered, and dorsalgia, that is pain to suffer in the spine, in the middle area of the back. You can see in the imagine the part of the back who is the suffer the hurt.
Conclusion, this analysis, that the activities that our employees were doing were really harmful to their health. These analyses in ergonomics are really helpful to find out which part of the activity is making trouble. We, in this case, find out that the distance was the principal problem, and the way that the employees were handling this aluminum was being problematic with their health. But with the correct application of these tools that we've been provided with, we can reduce these risks, reduce costs on absences and on injuries of employees, raise earnings out of production, and block all these wastes on injuries of employees, because right now is really less probable that one of them has a DT problem out of repetition of muscular charge. Thank you.